Hey everybody, this video lesson is going to cover our last type of naming with covalent molecules. Now what sets naming with covalent molecules apart from ionic molecules or ionic compounds is that covalent molecules are always nonmetals bonded to nonmetals. This is different from ionic compounds because ionic compounds are always metals bonded to nonmetals. So you know you're working with a covalent molecule when you look at the first element, and if the first element is a nonmetal like carbon, nitrogen, or oxygen, or sulfur, or something like that, then you are working with a covalent molecule. The example nonmetals that I listed would be the ones that you begin the molecule with. Of course, they'd be bonded to something else like hydrogen on the back end or a halogen or something like that. But the first element is one of these nonmetals. It could be others, but these are your common five. Here's an example. Take CF4. Now, the rules for naming covalent molecules is quite simple. The first element, the first nonmetal, keeps its name. So in this case, carbon remains carbon. Now the second element drops the ending and adds IDE, similar to a basic ionic naming. So in this case, it would be fluoride. Fluorine becomes fluoride. Now, so far, this doesn't set itself apart from ionic in any way, really, except for this last thing. For both elements, you need to use a prefix before the name to represent how many of the atom you have in the molecule. For example, if you have 4-fluorine, you use the prefix tetra. Tetra stands for 4. Now, the prefixes are listed on the back side of your periodic table in the bottom left-hand corner. They are mono is 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so on. You can look at the bottom of the periodic table in the lower left-hand corner, the back side, if you would like to look at them 1 through 10. But the nonmetals, the first and second nonmetals, get prefixes. I'm going to scroll up a little bit to give myself some more room. But the rules for prefixes are as follows. The first element only gets a prefix if there's more than one of them. So if there's only one, like in this example, you don't use a prefix on the first element. Now the second element, or the second nonmetal, always gets a prefix. Even if there's one, you would put mono. So in the example of CF4, since carbon is singular, you just say carbon, but the fluorine is tetrafluoride. So the full name is carbon tetrafluoride. The word tetrafluoride is all one word. Now let's do an example where the first element is more than one so you can see when you would use a prefix. Let me scroll up to give myself some more room. Here's my example. P2Cl5. I'm looking at two nonmetals here. You've got phosphorus and chlorine. Now since there's more than one phosphorus, we will use a prefix on this first element. It is diphosphorus. And the second element is chlorine, and since there are 5 of them, we say pentachloride. So as you can see, we use prefixes for both the first element, since there's more than one, and the second element always, in this case diphosphorus, pentachloride. Now that takes care of naming with covalent molecules, but how do you write them? This slide is going to cover writing with covalent molecules. So in these examples, you'll be given the name and you'll be asked to write out the formula. Now what's nice about covalent molecules is that there are no charges to balance. Unlike ionic, you need to show your work, you need to write out the ions, write out their charges, and make sure that when the two ions combine that the charges balance. But for covalent, you just take the name, which will have prefixes in the name, and simply translate what you read to symbols and numbers. It's that simple. So for example, if you have something like dicarbon hexafluoride, it would look something like this. Another example would be dinitrogen monoxide. The word monoxide sometimes is said monoxide. Both are acceptable, but mono refers to one oxygen, and oxide, well, of course, refers to oxygen. So in summary, if you have the name and you're trying to translate to symbols, just simply translate the words to symbols. In both cases, it's quite simple to see the names translated to the symbols with the prefixes behind the symbols to represent the quantity. I'd like to take a moment now to kind of compare ionic and covalent and how you name to symbols and how you go from symbols to name. Take a look at the top part of this picture.
In pink I have ionic. It is a metal bonded to a nonmetal. But if you have a nonmetal bonded to a nonmetal, then it's covalent. So when you're going from names to symbols, it's important to know what the first element is, because if the first element is a metal, it's ionic, and if the first element is a nonmetal, it's covalent. Now, for ionic, you write out the ions, then you write out the charges, and then you balance those charges. And we practiced this in our video lesson. Now for covalent, you simply use words to translate directly. So if it says dicarbon, that's 2 carbons. Or if it says tetrahydrogen, you use 4 hydrogen. So there's no math and there's no charges. You let the prefixes decide how many you have. Now, when you're going from symbols to names, once again, you got symbols, you look at the symbol and you see that it's a metal, then it must be ionic. If the first symbol is a nonmetal, then it must be covalent. With ionic and covalent, the first element keeps its name, the second element drops the ending and adds IDE. But what you can see there in pink at the bottom is that you use no prefixes for ionic, but you need prefixes for covalent when you're doing the names. Again, if you see like C3, that means tricarbon, or H6 is hexahydride. I would take a screenshot of this if I were you and put it in my notes or copy it down so that you can see the difference between ionic and covalent when it comes to names to symbols and from symbols to names. Well, that takes care of this video lesson. Thanks for watching.